Hey, this is another one of the Math 215 help videos. This one is for Lab 7. You guys are liking them so much that I decided to make another one for the upcoming labs. So Lab 7, we'll just start off with problem 1. It wants us to create a t and a y array from our signal data. And so this just requires a little bit of knowledge on array indexing. So if you have a matrix that's, let's say, 3 by 4, to look at the first entry, we'd want to look at 0, 0. The first entry in the first the first entry in the first row, and then the second entry in the second row, we do that. And if we want to look at the entire row, let's say, we'd want to say the first row and everything in that row. That's what that colon means. And if we want to do like the first column, we'd say we'll look at all the rows, and we want to look at all of the first elements in all those rows, which will be the first column. And so just remember that when you're doing problem 1. And remember, when you're plotting a function, you'll use plt.plot. You'll throw in your x array matrix, and then you'll throw in your y, or your x vector and your y vector. So it can have those corresponding points, y points to x points. So just remember those for problem 1. For problem 2, I'll step through it because this is probably the hardest one on the lab. And so the first thing that I notice is that we have cosine of 1 times t, and then sine of 1 times t, then cosine of 2 times t, sine 2 times t, so on until we get to n. So the way that we'll want to do that for loop, and I'm just going to start it as a for loop and then I'll do list comprehension. I'd say for I in range, length, or really quick, range, remember, starts at 0, but I'll want to start at 1 instead. And so I'll say 1, and then I'll want to do n plus 1 because we want to include n, so we'll go past n1. So for I in range 1 to n plus 1, I want to add, let's just say cosine for right now, cosine of I times t. And I'm just going to write that because I'll explain now when we go into list comprehension. All we need to do basically is just put whatever we're adding in front of that for loop. So we can say L, if that's our list, equals cosine of I times t for I in range 1 to n plus 1. So that's how we'll convert it into list comprehension. Now, keep in mind that we actually want to add two things right here. We want to add cosine, but we also want to add sine. And so they mentioned this a little bit in the textbook, but I think the best way to do that is create another for loop. So we'll have something here, we're not sure yet. We'll have our original for loop for I in range 1 and n plus 1. And then for every I, we want to do a cosine and a sine. I'll try to move that up so you can see it a little better. We want to do a cosine and a sine for every I. So what I'll do is for j in, and then I'll just make an array of our cosine and sine functions. And I am really running off the edge here. Hopefully you can see that. So we can say for each I want to add a cosine and a sine. So the way that we'll then do that, the thing that we'll put in here is we want to say j, because that's our function, cosine or sine, and then cosine of our I times our t. And so that's what you'll put in for problem 2. So yeah, say that right there. So that's what you'll put. And that will be your row function. Now for problem 3, it'll be something similar. And it's just saying we want to make a matrix such that each row is going to be basically row function with t at 0 and n, which they specify for us. So we don't need to worry about that n. And so another example is the next row would be row function of t at 1, n. And this will repeat as you go on. So looking at that, we can kind of extrapolate how to make another list comprehension. So what I would do is, we'll call this one M because it's a matrix. We want to iterate over these numbers. And so I'll call those I, and sorry, I'm going to erase this. We'll say row function of t, but then this is the variable that will vary on each row in our matrix. And so I'll call it I just for now, and n will always be the same. And then we want to iterate over that I, so we'll say for I in range, and then if we check what our I has supposed to loop over, it's for all the entries in t. So we can make sure we get all those by saying just the length of t. Because if we look at all the things in t, then we'll look at the length of t. And so yeah, that would be how you set up your problem 3. And I just went out these. I wrote the code for these ones because I feel like they're more difficult than the rest of the issues in the lab. So that's 3. For number 4, it's pretty self-explanatory. Just read the problem and make sure you're doing it for 2, an n of 2. For problem 5, I'm just going to refer you back to problem 6 that we did last week because it's basically the same exact thing as some of the problems that we did there. And for problem 6, just remember that when we're multiplying matrices together, we'll use this command. If we wanted to multiply together matrices A and B, that's an L, then we'd use that. But if we want to do the dot product of 2 matrices or 2 vectors, then we'll use the dot function. Remember, these are not the same. This is for a matrix multiplication, and this is for a dot product. And so for problem 6, you'll want to use a dot product. For problem 7, it's basically just running the code that they provide you. And then lastly, for problem 8, again, for problem 8, you're not going to do a dot product, and you're not going to do a normal matrix or a normal multiplication. So for that x and beta, you'll want to do the matrix multiplication like it has syntactically formatted here. And you'll use your actual beta term instead of just the character beta. And I think the same for the x. And remember that np.linog.norm, this just calculates the length of a list. So if you had a list that was 3 and 4, then if that was like a vector, then you'd have 3 going that way and then 4 going that way. And if you remember Pythagorean's theorem, that will be 5. And so the norm of this vector will be 5 because it's like the length of the vector. And so that's all that this is doing. And so when you put in a vector or a matrice, it will calculate the norm of it. And so that's how you use the norm when it's referring to this bracket notation. And then, yeah, just divide it by 629. And then for problem 9, this is an important thing for all of the lab, and I guess I probably shouldn't have said it at the end, but whenever it asks you to save a variable as something, so it said like save x2 as something, rather than writing out all the individual values that it prints, something like this, instead save it as the function that it's supposed to be. So x2 would be something like, I think it's like design matrix or something like that. So write it as a certain function rather than as a set of numbers or as a number. And that will be especially helpful when calculating your whole MSE 10, Pred 10, and so on. And the last one for that, so remember, yeah, to format it in that certain way. And remember, if you're doing suddenly MS10 instead of MSE2 or 100 instead of 10, you'll want to change that variable in 2 places. The first one is when assigning your x2. Instead, it's going to be x10, and so when you plug something in here, you should have one that depends on that 2 or 10 value. So you'll want to change it there, and then in your f2 function, or in this case f10, you'll do the dot product of beta 2, which in this case will be beta 10, and your row function of t and 2, but in this case it's 10. So just remember that you'll have to change that value in 2 different places in your code. But I think that just about wraps the lab up. Again, this isn't too heavy of a lab. There's just some really confusing concepts in it. And if you have any questions, you can reach out to me during my TA hours or just email me. So yeah, have a great time with this lab. Wish you the best of luck.